In this video, we continue our discussion on Chapter 12, in which we go over the profit maximization process for a monopolistically competitive firm. Where in our last video, we went over the characteristics of the monopolistically competitive market structure. In today's video, we seek to use that information to go over some preliminaries to discuss marginal cost, as well as marginal revenue, and conclude with the profit maximization process for a firm in the monopolistically competitive market structure. Where, beginning with our preliminaries, as we saw when we were discussing prior market structures, to go through the profit maximization process for an individual firm, we will need two items. The first being our firm problem, maximize profits subject to the production constraint, and the second being our market structure assumption, in this case monopolistic competition, which entails the 7 characteristics of many firms in the space, whom are profit maximizers selling a differentiated product in which low barriers to entry exist in the space. Each firm has market power due to selling differentiated products, allowing for brand loyalty. Each firm makes independent decisions, and we will expect zero economic profits in the long run. Where with this information in mind, to continue, let us proceed by example, where suppose we are considering a coffee shop in the iced coffee industry that produces iced coffee using a fixed amount of capital and a variable amount of labor, where we have their short-run production function below, fixed amount of capital, a variable amount of labor, which we see on the horizontal axis, and it's going to be the percentage of the labor force being used, and we have output on the vertical axis in terms of iced coffee produced, where we see that as the percentage of the labor force increases, the quantity of iced coffee produced increases as well, and it's going to be so at a decreasing rate due to diminishing marginal returns, where these two properties on a production function are what we've seen in prior analysis. So then now moving on to our cost structure. For costs for this coffee shop, suppose that there are fixed payments on capital of 10 cents and the labor force is paid a wage rate of $1 if the entire labor force is used. In order to generate total costs, we need to sum fixed costs and variable costs. Beginning with fixed costs, if we turn to our production function, regardless of the labor that's being used to vary our output that's being produced, our fixed payment on capital of 10 cents will remain the same. So regardless of output, fixed costs will remain at 10 cents. So then now proceeding on to variable costs, this will correspond to our wage rate, which we know is $1 if 100% of our labor force is being used. So then our variable cost will be scaling our wage rate of $1 by the amount of labor that's being used at each point, such that variable cost will vary between $0 and $1. So then summing our fixed and variable cost components together, we can generate total cost for points A along through F, where we see that total cost varies from 10 cents all the way to $1.10. Using this to generate our graphical representation on the left, we have cost on the vertical axis, iced coffee on the horizontal. We have total cost in purple, where at point A, when zero output is being produced, we see that total costs are non-zero, and this is going to be due to our fixed costs. And for our remaining points, we see we have an upward sloping total cost curve, and this is going to be due to our upward sloping variable costs, as we've seen in prior analysis of costs as well. So then using this information, we can then compute marginal cost, the rate of change of costs. That is, if there's a 1 unit change in production, what is the corresponding effect on total costs? This is just going to be the slope of our total cost function on the left. So we can calculate marginal cost using our table representation in the middle to generate our marginal cost curve on the right. So we just want to consider the rate of change in costs going from point A to B, B to C, C to D, D to E, and E to F. Where we see going from A to B to produce that first iced coffee, we see that total costs are changing by 40 cents. So at point B, this generates our first point on our marginal cost curve of 1 iced coffee with a marginal cost value of 40 cents. We see going from B to C to produce that second iced coffee, costs are changing by 60 cents, generating that second point on our marginal cost curve, point C. Going from C to D to produce that third iced coffee, we see that total costs are changing by positive 80 cents, generating point D on our marginal cost curve. Going from D to E to produce that fourth iced coffee, we see that total costs are changing by $1, generating point E on our marginal cost curve. And for our last point, going from 4 units of iced coffee to 5 being produced, we see that total costs are changing by $1.20, generating point F on our marginal cost curve, where we see that we have an upward sloping marginal cost curve, which is going to be due to diminishing marginal returns on labor. So with our cost and marginal cost structure considered, moving on to revenue. For revenue, since the coffee shop is a monopolistically competitive firm, they have some market power due to selling a differentiated product, which in this case we can think of as the size as well as the flavors offered in terms of their iced coffee, as well as amenities offered at the coffee shop as well. This would then grant them brand loyalty, which will then establish some market power in the overall iced coffee industry, and as a result, they will face a downward sloping demand curve for their individual iced coffee, where, to iterate, the demand curve that they are facing is for their individual iced coffee. It is not the market demand curve for overall iced coffee. Where, having that noted, we have iced coffee demand for this individual coffee shop below, where prices on the vertical axis, quantity of iced coffee on the horizontal axis. We see we have a downward sloping demand curve for this iced coffee for this particular coffee shop, in which there's an inverse relationship between price and quantity demanded as expected. And using our table representation in terms of calculating total revenue for the coffee shop, this is going to be looking at each point on the demand curve and scaling quantity demanded by our price point, which will generate total revenue, where we see that total revenue is increasing from points B to D, is stagnant from D to E, and then begins declining from E to F. So then, using our total revenue structure and our demand for this particular iced coffee from this iced coffee shop, we can find the rate of change of total revenue or marginal revenue. If there's a 1 unit change in output sold, what is the corresponding effect on total revenue? So to do this, we'll consider our demand curve on the left, our table representation in the middle, which includes total revenue, in order to compute marginal revenue on the right. So this is going to be comparing the revenue change given output sold from B to C, C to D, D to E, and E to F, where we see going from B to C, output sold changes by 1 unit, in which we see the change in total revenue is going to be a positive value of 80 cents, generating point C on our marginal revenue curve. From C to D, selling 1 more unit of iced coffee, we see that total revenue is changing by a positive value of 40 cents, generating point D on our marginal revenue curve in green. Going from D to E, selling 1 more unit of iced coffee, we see that total revenue is changing by 0 cents, generating point E on our marginal revenue curve. And going from E to F, selling 1 more iced coffee, we see that total revenue has declined by 40 cents, generating point F on our marginal revenue curve, where we see that marginal revenue is downward sloping and is in green, and is strictly below our demand curve for iced coffee for this particular coffee shop. So then, with marginal cost and marginal revenue computed for this coffee shop, we can put the two together and look at the profit maximization process for this individual coffee shop, where we have price on the vertical axis, quantity of iced coffee on the horizontal axis, downward sloping demand curve for this individual coffee shop and their iced coffee, downward sloping marginal revenue curve in green below our demand curve, and our upward sloping marginal cost curve in black, and it's upward sloping due to diminishing marginal returns on labor. We know our profit maximization rule is marginal revenue is equal to marginal cost, but considering our other cases first, looking at points B and C, we see that marginal revenue is strictly above marginal cost, so additional money flowing into this firm is greater than additional money flowing out of the firm due to their additional amounts of production using additional amounts of labor. So at these points B and C, this firm has incentive to produce more in order to generate more money. So this does not satisfy our condition of marginal revenue is equal to marginal cost, where if we turn our attention to points D through F, we see that marginal cost is strictly above marginal revenue, such that additional money flowing out is going to be greater than additional money flowing in, such that using additional amounts of labor to produce additional amounts of iced coffee is not worth it, and they should scale back on production. Where if we look at the points between C and D, we see marginal revenue is equal to marginal cost, which we'll designate as point G, where at this point additional money flowing in versus additional money flowing out from using an additional amount of labor to produce an additional amount of iced coffee will break even, such that if the firm were tried to produce more, they would then be incurring a loss and have incentive to produce less. Whereas if they were to produce less from this point, they could be generating more money and would have incentive to produce more, such that at this point, point G, marginal revenue equal to marginal cost, there's no incentive to produce more or less iced coffee using additional amounts of labor. Where at this point, this generates our profit maximizing quantity in terms of iced coffee. We're looking at point G in our table representation. We see corresponds to 2.3 units of iced coffee. And since this firm is monopolistically competitive and they have market power, as we did with the oligopoly and monopoly case, they then use this quantity level to move up to the demand curve and use this in terms of their pricing strategy, where on the demand curve at point G, 2.3 units of output, we see that households are willing to pay a price point of 92 cents. So then our profit maximizing process leads us to point G for our profit maximization rule, in which 31% of the labor force is used to produce 2.3 units of iced coffee at a price point of 92 cents. Where overall what we saw then was profits were maximized at a rule of marginal revenues equal to marginal cost, no incentive to produce more or less from this point, where this generated our optimal level of output to produce and sell for the coffee shop, where in terms of the pricing strategy, this then led us to move up to the demand curve to see what households were willing and able to pay at this particular quantity level, since they have market power due to the differentiated product and their brand loyalty that's established from the differentiation. We're looking at this bundle then, looking at a production function. This then entails going to point G, producing 2.3 units of iced coffee using 31% of our labor force. We're going to our profit maximization process. 2.3 units of iced coffee corresponds to when marginal revenue is equal to marginal cost, where our price point on the demand curve corresponds to 92 cents. So then, now we want to see if this firm is generating positive economic profits, a loss, or should shut down. So to do so, let us incorporate average total cost so we can consider profits, which recall is the difference between price and average total cost, scaling that difference by total quantity, and that'll give us overall profits. So in terms of average total cost, looking at our table representation, recall that this is just going to be total cost divided by quantity produced at each point, where if we take total cost and divide it by quantity from points B along through point G, we can generate our value for average total cost, which will be decreasing when average fixed cost is dominant, but increasing when average variable cost is dominant. So then using this information to generate our purple U-shaped average total cost curve in our profit maximization process, we can then compute profits using our rule of price minus average total cost and scaling that by overall quantity. Moving to our profit maximizing rule, marginal revenue is equal to marginal cost, gives us our output level of 2.3. Moving up to our pricing decision, this is going to be up on our demand curve, which is we know is 92 cents. We see that our pricing strategy, or the point on the demand curve, is strictly above our purple average total cost curve. So price minus average total cost will be positive, such that there will be positive profits per unit, such that when we scale that by our overall quantity level of 2.3 units of iced coffee, we will see that there will be positive economic profits. To see this, recall once again, our profit maximization bundle is to use 31% of our labor force to produce 2.3 units of iced coffee and sell it at a price point of 92 cents, where there's positive economic profits since our price point is 92 cents. Excuse the 91 cents here. Our average total costs are 58 cents, such that the difference between price and average total costs will be positive, such that when we scale that by our quantity level of 2.3 units of coffee produced, this generates positive economic profit value of 78 cents. So then to recap our profit maximization process for the monopolistic competitive firm, they have some market power such that they face a downward sloping demand curve due to their market power from selling the differentiated product with brand loyalty attached, where they will have a downward sloping marginal revenue curve as a result, where profits are maximized when marginal revenue is equal to marginal cost, giving them their optimal level of output, where they price along the demand curve in which they are capable of generating positive economic profits, at least in the short run.